1.
All right, I'm doing a quick mini lesson here on 1.2 graphing functions. We didn't get to go through all of this in every class today, so I thought I'd go ahead and make these and post them online so you guys can look at them if you weren't here, or because we didn't get to do everything that I wanted to in class because we wanted to answer everybody's questions. So let me first get rid of that. You don't need to see my face all the time. And let's talk about section 1.2. Section 1.2 is about graphing functions. It's about graphing. Come on, baby. Functions. Okay. There's basically two things that we're trying to learn or trying to get across in section 1.2. Those are using input-output chart and choosing appropriate inputs. Let's start with the input-output chart. An input-output chart is simply a T-chart. You're used to those. You've been using those for years. We got X and Y, or now that we use function notation, we got X and f of X. Sometimes there'll be what we call a lazy T-chart. Why is it lazy? Because it's laying down. So we got an X and a f of X. Remember, f of X and Y is the exact same thing. Now, the X is also known as the input. And then the f of X or the Y is known as the output. We are going to use this chart, and we get to choose the inputs. I think that's what everybody forgets over and over again. Where do these inputs come from? We get to choose the inputs or input values. And we're going to talk about choosing appropriate ones in just a second. But we get to choose them. Now, some things that I'd like you to always think about when we're choosing. We should almost always, I don't want to say always, but almost always have 0. Why? Because 0 times anything is 0. It makes total sense. I want you to choose easy inputs. That makes sense. Okay, use easy inputs. So 0, 1. 1 would be very popular because 1 times anything is whatever you're multiplying it by. 2, that's another easy one to do. Now, we could keep going on and go 3, 4, 5, but in all reality, I would also like you to go on either side of the y-axis or do some positives and some negatives. That would be awesome if we did that when we chose our inputs. And then once we have an input, I'll see if I can move this little thing down here. Here we go. Okay. And once we have our inputs, then we plug it in and evaluate to find, find the outputs. So let's say, let me go red. Let's say I had the function f of x equals, I don't know, 2x. Then I plug each one of those in. Negative 2 times 2 is a negative 4. Negative 2 times a negative 1 is a negative 2. 2 times 0 is 0. 2 times 1 is 2. 2 times 2 is 4. I want you to notice there's a reason why I like to use the negatives and the positives. Notice how those are very similar. It's not always just going to be the opposites, but because I didn't add or subtract anything. But sometimes it is. It's a big part of what we do. So we use input-output charts. Okay, we choose the input that we want, choose the easiest ones you can think of, then plug it in and evaluate to find the outputs. You've been doing that for a long, long time. Okay, that was the first thing we talked about in section 1.2. Now let's talk about choosing appropriate inputs. Now there's really only two things that were two main ideas. The first one is the square roots, and the second one was fractions. These are the main two things we talked about when we dealt with choosing appropriate inputs. Square roots and fractions. 1/3, 1/2, 1/5. Doesn't have to be 1, it could be 3/8. Doesn't matter. But fractions. Okay, so what did we say? Let's start with the square roots. We said we want to use perfect squares. You remember the perfect squares? 1, 4, 9, 16, 25, 36. Now, those aren't our inputs. That's not what I mean when I say use. When I say use, what I mean is I'm going to use those values. So let's say I have this function, f of x equals the square root of x plus 3. Okay, and I'm going to make my input-output chart. X and f of x. I'm going to use these values. I'm going to put them in red so they stay out there by themselves. 0, 1, 4, 9, 16, and so on. And then I think to myself, hey, what can I put in for x in here? What can I put in for x in here that would make that x plus 3 equal 0? Well, I could put in a -3. -3 plus 3 would equal 0. And then the square root of 0 is 0. What can I put in for this x to make x plus 3 equal 1? Well, I could put in a -2. -2 plus 3 is 1. 1 square, and then the square root of 1 is 1. What can I put in for this x to make... Hold on 1 minute, sir. To make x plus 3 equal 4, well, I can put in a 1. What plus 3 equals 9? 6. What plus 3 equals 16? Well, 13. And then I can take those square roots to be 2, 3, and 4. And then when it comes to fractions, I must use a multiple of the denominator. So, let's say I have 1/3. I would want to use numbers like 0, 3, and 6. Now, I could keep going to 9, 12, and so on, but I would rather you go -3 and -6. If I had 3/7, you would choose the numbers 0, 7, 14, but then I would also have you choose -7 and -14. Anyhow, there it is. That's what we talked about. Hope that works and is very helpful for you. Have a great day. Make sure you got your homework done.